Hello, I'm Warrant Officer Class 1 Pamford Richard, an instructor, and I've come your way once again with our lessons on forces acting on propeller, aircraft propellers. The last time we met, we touched on the centrifugal force, we touched on the thrust bending force. Today, I'll touch on the torque bending force. The torque bending force. Now, as propeller rotates or works, they encounters air resistance as the aircraft flies through the air. So this air resistance try to impede or restrict on the movement of the propeller. So you say thrust bending force, or sorry, torque bending force tries to bend the propeller blade back in the direction opposite to the direction of rotation. So as you can see on the picture, when the propeller tries to move or is made to move clockwise, there is this air resistance in between the propeller that tries to move the propeller back in the opposite direction of rotation. That is a force that is present there as at that moment that the propeller works. So on the other picture for a four-blade propeller, you will see as the propeller also rotates clockwise, there is this thrust bending force that tries to move the propeller back in the opposite direction of rotation. So this force, which is torque bending force, is as a result of air resistance that it finds itself in between the propeller blades as the aircraft flies against the direction of the wind. Our next force that we will touch on is aerodynamic twisting moment. Aerodynamic twisting moment. The aerodynamic twisting moment tries to twist blade to a higher angle. This force is produced because the axis of rotation of the blade is at the midpoint of the chord line, while the center of lift is of the blade is forward of this axis. So when you talk about aerodynamic twisting moment, it is the force that tries to increase the blade angle. It tries to increase the blade angle because the propeller has a common plane it rotates about. So as it rotates, it has a center of rotation that it rotates on. At the same time, because the propeller needs to be tilted, either up or down or change its angle, there is this possibility of the angle being increased by virtue of the propeller blade's natural phenomenon or force that exerts over there. It is because the lift that is generated by the propeller is at a certain position, and then the center of rotation is also at a certain position. So on the diagram or the picture, you realize that the center of pressure simply means that where the total lift or thrust is said to be concentrated, you realize that it is at the forward of center of rotation. But because the propeller can move, can rotate, or can be tilted at an angle, you realize that because the center of pressure is in front, as it works, it tries to move because the center of pressure is at the front. So it's trying to move upwards to alter the blade angle to a higher angle. That is aerodynamic twisting moment. It's as a result of center of pressure and then the center of rotation. The center of pressure is forward, which is a lift. It tries to move up, and then because it can also be tilted up or back, and then you have the center of pressure at that moment, it causes it to move in a higher angle. There's other picture here that also shows the same aerodynamic twisting force over here. The yellow picture you see is the propeller cross-sectional area. The red is the center of pressure or center of lift, and then also the center of rotation is what you are viewing over there. So because of the center of pressure is forward of center of rotation, it tries to move the blade to a higher angle, which is aerodynamic twisting moment. This force tries to increase the blade angle. It's a force that occurs on the propeller. The next one we will touch on is centrifugal twisting moment. The centrifugal twisting moment here opposes the aerodynamic twisting moment in a certain degree. It is the moment that tries to decrease the blade angle and oppose the aerodynamic twisting moment. The tendency to decrease the blade angle is produced because all part of a rotating propeller tries to move in the same plane of rotation as the blade center line. What it simply means is that as the propeller rotates, because the leading edge, the mass or the weight there is greater, it also tries to move down to decrease the blade angle, whilst the centrifugal force tries to also increase the blade angle. So with the centrifugal twisting moment, it tries to decrease the blade angle as a result of the mass of the propeller blades. The leading edge having enough mass or enough weight as in its rotation, it tries to decrease the blade angle, while the aerodynamic twisting moment tries to increase the blade angle. That's another picture you see over here, the leading edge and then the trailing edge of the propeller. Because it is in aerofoil section and it rotates, the mass being greater at the leading edge try to move down, exert its weight down, and then by so doing decreasing the angle of attack, or tries to decrease the angle, blade angle over there. So viewers, we will end here, and then I'll come your way on forces acting on the propeller the next time I meet you. Have a wonderful day.